Okay, let's unpack this. I have a thought experiment that I think is, well, it's almost too perfect for what we're talking about today.
I'm intrigued.
I want you to imagine, just for a second, a 12th century version of an AI.
Okay.
Let's call it the Scholastic Engine. It's this incredible machine built by monks, and it has been fed every single manuscript they have, the entire known textual universe for that part of the world.
Right, the whole scriptorium.
The whole thing. Now, you asked this medieval AI a really basic question. What is the shape of the Earth?
It's because they flat.
It confidently declares the Earth is flat, as scripture and common sense affirm. And here's the point, the real hook for our deep dive today. That's not a flaw, it's not a bug. It is, in fact, a successful modeling of its dominant data landscape. It just perfectly mirrored what it was fed.
That historical parable, it just perfectly frames our mission today, doesn't it?
Yeah.
We're looking at this core paradox in modern AI
Ex-
because it's a mirror of its data, the entire internet, basically. It is mathematically almost forced to reward the average of what we all say.
The average.
And in doing that, it just systematically pushes aside the exceptional, the nuanced, and I think most critically, the truly novel ideas that are what actually drive progress.
So this is what we're calling polished mediocrity.
That's the threat. Our deep dive today is all about mapping that risk, the risk of building a world that's defined by this polished mediocrity.
So we're looking at how these algorithms, which are, they're designed for efficiency, they end up smoothing over all the important rough edges of human thought. To really get a handle on this, we're going to explore 3 specific areas.
Okay.
First, knowledge systems, how AI is flattening what we even consider to be true. Then we'll jump into the world of engineering and code, where the conventional solution wins out over the elegant one.
Huge one.
And finally, the big one, the sociocultural impact this has on creativity, on culture, on everything.
So let's start right there with that epistemic flat earth. Back in our medieval example, the bulk of the texts, the religious writings, the popular cosmology, they all statistically screamed flat earth.
Right.
The few scholars who knew otherwise, who had read the old Greek texts, they were statistical outliers.
So the AI would just dismiss them.
It would have to. It can't go out and check for itself. It can't do an experiment. It only models the text it has.
And this is where it gets really unsettling in today's world. We've got a perfect modern case study. It's a phrase from Confucius's Analects.
Ah, yes, exactly.
Now, if you come at that phrase through centuries of actual scholarship, what we call the hermeneutic tradition, it has this very precise, very deep meaning. Something like, have I not practiced what has been transmitted to me?
It's about embodying knowledge, not just knowing it.
Precisely. It's about that deep integration of knowledge and practice.
And it's rooted in context, right?
Yeah.
In this whole lineage of who wrote what and when. It has authority. It has authority, yes. But a modern AI, it doesn't see that lineage. It treats all digitized text as, well, basically equal. So it spits out an interpretation that sounds plausible, it's grammatically correct, but it's subtly wrong.
Because it's mixing that high-quality scholarship with what?
With digital noise, it's giving the same weight to a 10th century commentary as it does to, say, a 2010 Reddit thread where someone just completely misunderstood the grammar.
Wow.
So the AI just optimizes for what's most frequent. It doesn't have a built-in authority meter.
Yeah.
And the result is this new distorted consensus, flattened epistemology.
It's not an outright lie, but it erases all the debate, all the subtlety.
It replaces it with a statistically safe average.
Yeah.
This is the pattern everywhere. It canonizes the most repeated facts, even if they're common misconceptions. It smooths over contradictions. Truth becomes the statistical mode.
And when truth is complicated, the mode is almost always just the average.
It's a consensus reality built by algorithm, not by inquiry.
That makes a terrifying amount of sense on the philosophical level. Okay, let's shift gears. Let's see how this same logic, this preference for the average, affects the really practical world of software engineering.
Yes.
We're going from flattening truth to flattening functionality.
And this is such a great place to look because code is, pretty binary. It works well or it doesn't. And we see this bias toward the common approach, just systematically crushing more elegant, more clever solutions.
So let's talk about the Sentinel node. For anyone listening who isn't a coder, break this down for us. What is it and why is it considered elegant?
Okay, so think of a linked list as just a chain of data. When you write code to manage that chain, adding a link, removing one, you spend a lot of time writing checks for the edge cases.
Like, what if the chain is empty?
Exactly. Is the list empty? Are we at the very end? You have to write all these ugly, repetitive if statements, like if head equals is NLL.
Yeah.
It's tedious.
And probably error-prone.
Very. The Sentinel node is the clever fix. You add a permanent dummy node at the start of the chain, so the list is never truly empty.
Ah.
And since it's never empty, you get to delete almost all of those annoying edge case checks. The code becomes cleaner, simpler, less buggy. It's just better.
So wait, if it's genuinely better, why isn't it the standard everywhere? Is it just inertia?
It's mostly inertia, and that's the heart of the AI problem. Because the Sentinel node is a bit more of an advanced trick, it's often skipped in beginner textbooks and online tutorials.
The stuff aimed at a quick fix.
The quick fix, exactly. So it's statistically underrepresented in the giant ocean of code online that these AIs train on.
So when you ask an AI to write code for a linked list,
It almost never suggests the Sentinel node. It defaults back to the clunky, repetitive, naive way of doing it, just because it's seen that if head-BDL pattern millions more times.
but the clever solution gets suppressed. The AI is actually making our code less efficient because it's afraid of the statistical outliers in its own data.
And it's not just about efficiency, it's about safety.
Right, you had that example of the fraction class for handling mathematical fractions.
Absolutely. Any good engineer will tell you, rule one is you have to check for division by zero. It'll crash your program.
But the AI doesn't always do that.
No, because it sees so many examples from quick online tutorials where the developer just skips that check.
Yeah.
To keep the example short, so the AI learns that reckless, incomplete code is a common pattern.
It's rewarding recklessness because it's frequent. That's terrifying. And this same logic, it reinforces monopolies in the software world too, right?
It absolutely does. The AI will always default to the most popular tool, not necessarily the best tool for the job. In C++A, for example, it will almost always suggest std.vector.
Okay, for the non-C++ folks, what's the difference there? Why does that choice matter?
std.vector is sort of the default container. It owns and manages a chunk of memory. It's useful, but it can be heavy. std.span is much newer and, in many cases, better. It's just a lightweight view onto data that already exists somewhere else. No copying, no memory management. It's incredibly fast and safe.
But the AI doesn't pick it.
Rarely. Because std.vector has been the default for decades. It appears billions of times in the training data. So even when std.span would be a much better, more modern solution, the AI defaults to the old way. It keeps innovative tools in their niche and just reinforces the dominance of whatever is already popular.
So to really understand the gravity here, we have to look at the why, the mechanism behind it all.
Exactly. We have to look at the math. A generative AI at its core is trained to do one thing: predict the most probable continuation of a sequence. It is always, mathematically, aiming for the center of the bell curve.
So if you give it the sentence, the cat sat on the
Yeah.
bins, its whole job is to pick the word that happens most often in that context. It's going to reward mat or sofa.
And it will heavily penalize something like quantum entanglement, not because it's wrong, but just because it's statistically bizarre.
So it's not a choice. It's not deciding to be mediocre.
No, it's a mathematical mandate. The loss function literally penalizes novelty. Uncommon ideas, unique ways of phrasing things, they're less frequent, so the model learns to avoid them.
And this gets layered on top of the fact that its training data, the internet, is already a massively distorted mirror of reality.
Oh, massively. You have linguistic bias, with English just drowning out most other languages and their entire intellectual traditions.
Then you have recency bias, where a brand new blog post can get more attention than a foundational text from 50 years ago.
And popularity bias. Wikipedia, major news outlets, social media, they are hugely overrepresented compared to, say, a niche academic database with groundbreaking research.
Which brings us to what you call the average of all think tanks problem. If you took policy papers from every think tank from the far left to the far right and you average them all together,
You wouldn't get some brilliant new insight. You'd get a watered down, conflict avoidant, basically conservative proposal.
safe, plausible, and completely uninspired.
LLMs do that with human language on a global scale.
And this is where we see the really high cost. The loss of intellectual diversity. I mean,
Right.
history is driven by outliers, right? Galileo, Einstein. Their ideas were not the consensus.
Not at all. An AI trained in Galileo's time would have confidently spit out the accepted geocentric model. It would have flagged Galileo's work as a statistical error. If we lean on this too much, we risk an intellectual monoculture.
And a cultural one, too. We saw it with the Confucius example. All the subtle meanings, the things that make a culture unique, get flattened into a generic, globally acceptable translation.
Homogenized.
Yeah.
And this leads to what I think is the most dangerous part of all of this.
The feedback loop.
The conformity feedback loop. It's terrifying because it's self-reinforcing.
Okay, break down the stages for us.
Stage 1. The AI starts pumping out huge amounts of this average, statistically safe content. Articles, code, whatever. Stage 2. That content floods the internet. Stage 3. The next generation of AI gets trained on this new internet, which is now saturated with the output of the last AI.
Oh, no.
Stage 4. The definition of average gets narrower. The bell curve gets tighter. The AI becomes trapped in an echo chamber of its own creation. The Overton window of what it could even generate just shrinks and shrinks.
Okay, that sounds incredibly dire. But we don't just have to accept this, right? We're not saying throw the mirror away.
No, not at all. We have to learn to use it with intent. We have to stop using AI as an oracle that gives us the answer and start using it as a tool that reveals our own collective biases.
So how do we do that in practice?
The first principle is curation over compression. We have to prioritize quality and authority in the data.
Meaning what? We just put filters on the internet.
It means being intentional. For specialized AIs, it means using expert curated data sets. For that Confucius example, it means only using verified scholarly commentaries for fine-tuning. It also means implementing weighted sources.
So you tell the system that a peer-reviewed journal is worth 10 times more than a random blog post.
Exactly. You give weight based on authority, not just on how many times something appears online.
Then you have to intentionally introduce good noise.
That's what we call deliberate diversity. You intentionally find and amplify the rare, the minority, the contrarian viewpoints in the training data. You're explicitly telling the model, pay attention to this outlier. It's important.
So that's on the data side. But as users, we also have to change how we interact with it, the human in the loop strategy.
Yes. Instead of asking for one answer, we need to use what are called probabilistic diversity prompts.
So instead of what happened here, you ask.
You ask, give me 3 different perspectives on this event and make sure one is the least common academic interpretation. You force it out of its statistical comfort zone.
I love this next idea, developing eccentric AI. What does that look like?
An eccentric AI is a specialized tool. You fine-tune it only on outlier texts. Imagine an AI trained only on the entire global patent database.
So its baseline for normal is novelty.
Precisely. Or one trained on avant-garde literature or breakthrough scientific papers. You're creating a tool that is biased toward innovation, not conformity. An AI that's optimized for the unexpected.
And finally, we have to actively protect knowledge. Build digital biodiversity reserves.
This needs real investment. We need to preserve niche databases that sit outside the big commercial web scrapes. We have to fund projects to digitize rare materials, manuscripts, journals in minority languages, things that only exist on fading paper right now.
So you're creating safe havens for non-average knowledge.
And for very specific domains, you can even create untrained modules. AI tools that start with almost no prior bias and are guided entirely by human experts. It prevents the global average from messing up a domain where precision is everything.
So if we pull all this together, the real takeaway is that if we outsource our curiosity and our creativity to a machine that's trained on the average, we risk building a world that is, polished, plausible, and just profoundly mediocre.
That's the warning. We have to remember that the real breakthroughs, the revolutionary ideas, they have never ever come from the center of the bell curve. They come from the edges, from the outliers. Our job in this new age is to make sure those edges don't get smoothed away. We have to find ways to illuminate them, to amplify them, and to preserve them.
So a future that's truly intelligent isn't one that just replicates what's common. It has to be one that values what is rare. Not just what's popular, but what is true, even if that truth is a statistical anomaly. Not just what has been, but what could be. So here's the thought to leave you with. As you go about your day, think about where in your own work, your research, your coding, your art, you can stop asking for the average answer. Where can you deliberately introduce a little eccentricity in your next prompt and challenge the consensus?